Hello, my name is Muhammad Adli bin Azman. For my group, our group will present about Laminar and tubular flow. Uh, for my session, I will talk about introduction and theory. For the introduction, as we know, a pipe is a closed channel that is used to channel pressurized fluid. Fluid in pipes is used for the purpose of moving fluid from one place to another place. In these sessions, we will look at the important points of the analysis of flow system in pipes. And we will discuss here is the effect of pressure change of incompressible fluid flow in the pipe and the flow system that will affect the flow analysis in the pipe. Next, the analysis of pressure change or column loss can be divided into two parts, which is first the main column loss occurs because of the friction that occurs in the flow of the pipe. Second, the minor column loss, which is caused as result of the pipe components used in the system, such as valves, connections between pipes, change in the cross-sectional area of the pipe, and so on. Okay, for the theory, we divide to two parts, which is laminar flow and tubular flow. For the characteristics of laminar flow, first, laminar flow is smooth and orderly flow with well-defined layers or streamlines. Second, laminar flow is fluid particle move in parallel path with minimal disruption between layers. Thirdly, laminar flow typically occurs at low velocities, and the velocity profile is parabolic with the highest velocity at the center of the pipes. And for the Reynolds number of laminar flow is 2300 and below. Second, for the turbulent flow, characteristics of turbulent flow is chaotic and irregularly fluid motion characterized by vortices, eddies, and fluctuations, common at highest velocities. Thirdly, turbulent flow is result in increased fluid resistance, and velocities profile are flatter, and the maximum velocity may not be at the center of the pipe. And lastly, for the Reynolds number of turbulent flow is 4000 and above.
Hi, my name is Ahmad Shazli bin Shu'id. Uh, I'm a member of Group 5. I would like to share the materials we use for the experiment. The first material is aquarium, used to channel water to observe flow, turbulence, and laminar condition. The second material is tube, employed to observe flow, turbulence, and laminar conditions. The next material is pipe and syringe. Both are used to convey liquid. We use syrup and soap to observe turbulence and laminar movement. The final materials, or the last material we use, is water stopper, used to control water pressure for obtain process result in laminar and turbulent flow. Thank you. Just that for me.
Hi, my name is Izzadina Ben Azli and my number matrix is CB210007. Alright, I will explain about case study. In case study, we have two different case study because we need to calculate the laminar and turbulent flow. First, I will talk about laminar. Laminar is a syringe is supplied with 20 ml viscous fluid, which is shampoo. The syringe will be pressed for 10 seconds to calculate the velocity of the viscous fluid and Reynolds number. Alright, next I will talk about case study for turbulence. For the turbulence, we need to find the velocity first and to find the Reynolds number. From the formula, we know that the formula of Reynolds number is equal Re equal rho Vd over mu, which is rho is fluid of density, V is fluid of velocity, D equals to diameter of pipe, and mu is equal to fluid dynamic viscosity. After that, from the experiment, we know that the displacement is equal to 0.2 meter at the time in 3 seconds from point A to point B. We can find the velocity to find this experiment is turbulence or not. We will find it from the calculation, which is Aiman will explain in detail. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilham, one of the group members of Group 5. For my part, it's about the procedure for the laminar and turbulence flow. So for the first experiment, I will show you guys about the laminar flow. Okay, first of all, the material that we will be using for the laminar flow experiment is, the first one is aquarium, water. The water is to supply water through this pipe, and then the stopper, syringe and the hose. Okay, for the laminar viscous fluid, we use champagne. Okay, secondly, I have set up my stopwatch here. It is 10 seconds, so I need to press the syringe with the viscous fluid inside within 10 seconds of timers. Okay, so I will press this within 10 seconds. Okay, so after I press this within 10 seconds, we can see in the tube whether this experiment is laminar or not. Okay, so after the experiment of the laminar flow, we jump to the next experiment, which is the turbulence flow. So there is nothing difference, the setup between the laminar and turbulence flow, but the main difference is this one, the viscous fluid. The viscous fluid for the turbulence flow, we are using syrup. So after I press this, the first flow, as you guys can see, this one is point A, this one is point B. So the length is 0.2 meter. So the first flow from this until this will be recorded.
Kami aku tunggu ini.
Okay, so as you guys can see, I have recorded the time from point A to point B with a length of 0.2 meter. So for the turbulence flow, from point A to point B is 3.3 seconds. Okay, so that is all from me for the procedure part. In the next part is the calculation. The calculation is to determine whether this experiment is laminar and turbulence. So that is all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Luqman Akil bin Muhammad Zaiful Azhar. My matrix number is CB210188. Okay. Today I would like to present about the calculation laminar flow. Okay. First of all, we must know the formula. The laminar flow is from the Reynolds number. The Reynolds number is equal flow density multiply fluid velocity and multiply pipe diameter and divide by fluid dynamics viscosity. Okay, in our experiment, we from the laminar flow we have a shear. The volume is 20 ml. Okay, the time we are taking is 10 seconds, and diameter shear is 2.2 centimeter. Okay, and the dynamic viscosity we use water okay is 1.002 multiply 10 negative 3 Pascal. Okay, first of all we go the number one is calculation flow rate. Okay, the calculation flow rate, what you can see is we take the velocity volume of shear is 20 ml divided by 10 second. 10 second is from we press the shear, it took 10 second. Okay, next the two is convert flow rate to volume rate, flow rate. Okay, you can see is the answer 2 cm, okay, meters per second. The next is we must calculate the cross section area of the pipe. The result what we can see is 3.8 centimeter. Okay, 8 knots convert in meter. The number 4, we calculate the velocity. Okay, the velocity is from the Q per A. Yeah, okay. Yeah, is the result is 5.26, okay, millisecond. Okay, the last is calculate the Reynolds number. Okay, from the what we can see, the result is 1154. Okay, the the result is include is contain for the laminar flow in pipes. Okay, the Reynolds numbers is below to 2300 is laminar flow. Okay, that's all from me about laminar flow. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Nasruddin bin Muhammad Adaha. My metric number is CBs 210239. And now I'm moving to the next slide which is I will explain about the calculations in turbulence flow. And in the case study, we know that the turbulent flow in my experiment is I must to find the velocity first, because I have the displacement and I must to record it the times. So for the first step is we must to find the Reynolds number. As we can see that the Reynolds number formula is equal to rho Vd divided by mu, which is we call it as fluid density times velocity of fluids times diameter of pipe and also divided by the fluid dynamic viscosity. All the formula is we must to calculate in the SI unit. So if we want to from the Reynolds number, we must to know that the Reynolds number must more than 4000 if we want to tell it about the turbulence. Alright, nextly I'm moving on to my next point is step 2 is the calculate the Reynolds number. It is necessary to include all the relevant numericals parameter in the formula, which is we know that the density fluid is 1000 kilogram per meter cube and the diameter of the pipe is 0.022 meter and the viscosity dynamic is in 20 degrees Celsius is 0.001003 kilometer per meter seconds. And now what we have had a problem is we must to find the velocity. So I will moving to my next slide to show you about how to find the velocity. Alright, from this slide I will explain you about how to find the velocity. We already know that the displacement we find is 0.2 meters, and to find the times is what is the first flow to reach the displacement 0.2, and we find that and we recorded the first flow to reach the displacement is 0.3 seconds. So from that 0.2 meter and 0.3 second, if is it we can find the velocity? Yes, we can find the velocity because the velocity, the formula of the velocity is equal to displacement over the time. So my formula or my calculation is different about the laminar and the turbulence because I have to direct to the formula. Alright, for the final part is when we know about all the value where we find the velocity, and now we must to enter all the value to the formula Reynolds number formula. So the Reynolds number we will find about 1000 kilometer per meter cubic is multiplied by 0.667 meter per seconds and multiplied by 0.022 meters, and we will divide it to 1.0016 megapascals, and we find that the Reynolds number is equal to 14,650. So the Reynolds number is more than 4,000. So we will confirm that these calculations there is a turbulence flow. That's all for me. Thank you.
Assalamualaikum. My name is Muhammad Fawzakimi bin Abu Hassan from Group 5 Fluid Mechanic. My part to present is about recommendation. Okay, first is to prevent leak around the hole. We need to first point is mesh the hole diameter to the tube diameter to ensure the hole we make in the aquarium align perfectly with the diameter of the pipe tube. It eliminates gaps and prevent water leaks. Apply aquarium sealant. Once the hole is drilled, we apply a layer of aquarium safe sealant around the hole edge and at the base of the pipe tube. This creates a watertight seal and prevent leak. Second is pipe tube that connect with the aquarium tank is not steadily in the place because the pipe is elastic. We use a clamp or bracket to secure the pipe tube to the aquarium with a clamp or bracket specifically designed for aquarium plumbing connection. This prevent the tube from moving due to its elasticity. We also replace the elastic pipe tube with a rigid or semi-rigid alternative to provide stability and prevent displacement. Alternatively, consider using additional support bracket or clamp to secure the pipe tube in fixed position, minimizing movement that could lead to instability. And last, need to always fill up the aquarium tank with water as the aquarium tank has a leak. We already solved this problem by identify and repair the source of the leak in the aquarium tank promptly. This could involve resealing the aquarium, replacing cracked or damaged part, or addressing any other leaks. We also regularly inspect the tank for potential leak and perform preventive maintenance to avoid future issue because yearly defection allow for timely repair and minimize water damage. We also maintaining proper water level to avoid overfilling the aquarium as it can put pressure on the seal and connection, potentially leading to leaks. Maintain the water level within the recommended range for your specific aquarium. That's all from me. Thank you.
As for the conclusion, the mini project about laminar flow and turbulence flow that was conducted was successful. We learned a lot about how fluids behave under different conditions. The experiment showed that the flow behavior of water in a pipe can be characterized as either laminar or turbulent depending on the Reynolds number. This project contributes to a deeper understanding of the complex interplay between laminar and turbulent flow, advancing our knowledge of fluid mechanics. Thank you.